I'm Statler. And I'm going to tell you a bit about the... Oh, what's happened there? That was slightly worrying. I hope I couldn't do what he did to Laura. I'm going to tell you about the urine assay. So before I do that, this is the crowd of huge number of people who are behind what I'm about to tell you. And I'd like to just particularly pick out Jill, who is at the back of the room and is there, because everything, when I say I did something, actually Jill did it. I just take the credit. So Jill has been absolutely fantastic in organising this session with this whole day with Tracy, and thank you, Jill, for doing that. I wasn't going to show this, but since it was referred to earlier, I hope this room all knows that if you take aspirin, you reduce your risk of colorectal cancer, and we have nice guidance for that, but we'll be hearing later it's still not into play fully yet. And then last September, we finally got the other half of CAP2 published, which showed that a high fibre diet reduced the non-colorectal cancers by 60%. And we talked about a little bit about this last year, but basically you take a high fibre diet, it's good and it's not dangerous. And we will be telling you next year that we've finished CAP3 almost next spring, but we won't have the results until we've put all the numbers together. But we're basically comparing the 3 doses and we're now funded through to 2025 to complete that study to find out what the best dose of aspirin is. Okay, so what about testing for Lynch syndrome in the urine? Well, first of all, let me just backtrack to the development of this assay. So about 10 years ago, we were looking at this challenge of how do we find all the missing Lynch syndrome patients, and it was clear that we needed to be doing something a bit slicker on screening tumours, particularly colorectal tumours. You've already heard we can look for the proteins, and those are shown in that top left-hand corner, or we can do MSI testing. Now, the proteins work most of the time, not always, but there is a significant issue that only 3% of our cell pathology departments in the country are actually fully staffed. So it's an extra burden on them. And it's a pretty expensive test from Tristan and Ian's study many years ago. So it's a good test, but it presents some challenges. And of course, after you do that test, you then have to do a molecular test to sort out which ones go for germline testing. So it's a kind of 2-stage process. On the top right is the microsatellite instability testing using the old method developed by Promegrin, which has been the workhorse for 20 years, but it uses an old style technology because what you're looking for is changes in the lengths of bits of repetitive DNA. But the 5 bits that they use in that assay, excuse me, will not work on our next generation machines. So it has to be done as a separate test rather than just putting it into the main mix. You can just sequence the tumour and you can analyse what's called the mutational signature of an MSI high tumour, but that's expensive and it's slow, and we're already struggling to get everything through the molecular labs as it is. And the final way forward is to select particular bits of DNA which are analysable using our next-gen machines and look for changes in their length that are out with the normal variation. So you can see here, there's always a little bit of variation, but when you get all sorts of different lengths, it's clear you've got a major spelling mistake, and that's a sign of mismatch repair deficiency. So that's what we set out to invent. And I say we, actually I mean them. And so Mauro is a computational biologist, Mike is a molecular biologist, and these are our PhD students, Richard's now a postdoc. And this is basically the essence. So here you've got 8 G's in a row, and you've accidentally put 7 in instead. So that's a slippage, and that's real. And what we had to work out was how we differentiate that, a real change, from what's called PCR stutter, where the amplification is just a bit wobbly, which has caused all those funny jig-jag peaks. And we've done it. So we basically identified a whole set of markers which are exquisitely sensitive in between genes, so it doesn't matter which tissue you look at, and they will pick up this microsatellite instability. But crucially, because it's going through our next-gen machines, we can also chuck in a whole bunch of other stuff, particularly this BRAF mutation. I'm not going to go into all the science of this, but basically, if you've got a BRAF mutation, you probably don't have Lynch syndrome. And so when we're trying to target ourselves, if you're a BRAF negative MSI high, then that's the group we want to do the Lynch syndrome testing on. And that gets you down to about a 1 in 3 score rate when you do the germline testing. And so this is some work just to prove that it works. This is not, the old test needed an expert eye to interpret. This is absolutely barn door. So the green ones are the stable colorectal cancers, the red ones are the unstable, and you can see we can very clearly separate them on the biopsy blocks. These are the little snips that are taken from colon cancers when you do your endoscopy. And what we do is just take a slice of the whole block and then analyse the so-called composite curl, which is that set of black dots. Just to prove how sensitive it is, we actually tested, great cost and faffing around for Christine and the team, every single biopsy. And as you'd expect, sometimes the endoscopist misses the tumour, and so you get an MS stable biopsy, individual biopsy. But in fact, even these two here were labelled as not having any tumour content, but were still MSI positive, or one of them was on the borderline. But of course, if you just take a slice of all of them, then you don't need to worry about tumour content. So we now, everywhere in our region, all the pathologists just take 3 slices of every biopsy block that they get through and send them into us for analysis. And Helen and Lee were the first people, Lee's one of our trainees, to put this into practice on the top left. And here on the bottom right here, Lizzie Solis from Sheffield wrote some beautiful software. So this is what the lab scientist sees. It basically said, this is an MSI high, it's way above the line. We don't even say high and low anymore, it's just MSI, and it's BRAF positive, so we're not going to act on this one. If it was BRAF negative, then we'd say do Lynch testing. But we also chuck in, just for good measure, all of the other RAS mutations, because that helps you decide, for the oncologists, they have to decide which drugs to give you if you've got cancer. And if you've got one of these driver mutations, like BRAF, then there's a certain class of drugs that won't work. So this is useful extra information. So you're getting all for the price of one. And we've now got that in routine practice across our region. So with Kieran, my partner in crime in the NHS, we put in a grant and got a grant from what's called the SBRI programme from NHS England to give a technologist to every genome laboratory hub, although 2 of them subsequently turned it down for reasons I won't go into now. And so we've actually recycled that money into the Lynch nursing work that you heard about earlier. And basically, we've now rolled this out across the top half of northeastern Yorkshire. It's now into West Yorkshire. It's now established in Northwest, and it's established in North Thames and Southwest. So we're just about getting it into practice. One of the problems we ran into at the beginning was that we designed it so it took 2 days to do the lab work, and then we reinvented it thanks to the work of another one of our PhD students, Rachel. So this is a great idea from Mauro. About 1 in a million children is born having got Lynch syndrome from both parents.